let us study the parts of a single phase AC generator and how it works. Okay, so now see, this is a coil here. Okay, that is a stator which will not rotate. Okay, then we have this NNS, that is a rotor which will rotate. Okay, so rotor rotates clockwise direction. So when rotor rotates in the clockwise direction, the magnetic field also will rotate. Okay, remember the stator is stationary. Okay, and stator is connected to a load resistor. Okay, so this is the initial position of this uh, rotor here. Okay, so this part is the rotor. So now we know this part. Let's go to the other pictures now. So let us see the picture here now. Okay, how the magnetic field rotates, that will not know. Okay, so first at omega t is 0, that is the initial position. This was the north pole, so magnetic field points towards the north pole here, like this way. Okay, next we see after 90 degrees. Okay, that is after half rotation. Okay, okay, like this way. It rotates like this in the clockwise direction. So magnetic field rotates in the clockwise direction. Okay, so what happens? It will go up here. Okay, so the magnetic field will go up here. Okay, so this is the arrow mark here, and then if you see this magnetic field is there now. Okay, it will hit this coil here. Okay, and an EMF is produced. First, let's see in the first case what's EMF. Okay, so you can see all the magnetic field goes in the air only. No, it's going into there. So there is no EMF produced. It doesn't cut the coil much. But now you see the magnetic field in the second case will hit first SR, then it will hit the point PQ. Okay, now we must use the Fleming's right hand rule. Okay, to find the direction of the EMF. So now it states that stretch the three fingers of right hand mutually perpendicular. The forefinger shows the magnetic field, the middle finger shows the induced current, and thumb shows the force. Okay, so we see that when you consider this picture, when the magnetic field rotates, the force should be pointing towards the left side. Okay, so we can consider that the coil rotates in the anti-clockwise direction. Okay, so the actual coil is stationary. This coil is stationary. The magnetic field only rotates. Okay, so you must take this thumb to be in the left side direction. Okay, so we consider coil is rotating opposite to the magnetic field. So we keep like this way. Okay, and then thumb is showing the force. Okay, or the motion of the conductor. Then magnetic field points from down to top. Okay, then the middle finger shows the current now. You can see that like this way. So current will go from the top, you can see. Okay, top part you see here. It will go from P to Q. Okay, so current goes from P to Q here. Okay, like this way. Okay, then it will come like down here, then Q to R, then R to S, then it will go outside. Okay, so remember this, very important. So what is the direction of the current? Goes from P to Q using the Fleming's right hand rule. Okay, now what happens? Next one we can see at this position here, that is 2 pi by 2, there is pi here. Okay, that means 180 degrees. This magnetic field rotates like this way. Okay, it rotates clockwise. So the magnetic field, if you see, will be in this direction here. Okay, again you see the magnetic field goes into the air only now. Okay, so it doesn't cut the coil here. So EMF is very low, or you can say zero also in this case. Okay, next after another rotation, what happens? The magnetic field will go like this way. It will come down here. Okay, so magnetic field points downwards here. So what happens is, in this case, okay, it hits the coil here. You can see first it hit this PQ, then it hit this RS. Okay, then the EMF is induced in the opposite direction. Okay, so you can see the direction of the current here using the Fleming's right hand rule will be from S to R. Okay, so you see that first it was from P to Q, then it will go from R to S, but now direction is changed. R to S, then Q to P will go. Okay, this direction here. Then last one you see, again rotate clockwise. This magnetic field rotates clockwise. Okay, B is the magnetic field rotates clockwise, and then it will come like this way. Okay, like the initial position. Okay, so you can see in this case also the EMF will be 0. So let us draw dotted lines and then we will plot this EMF here. Okay, it's very easy. Okay, so first let me draw the dotted lines here. Okay, so it's easy to draw the graph. Like this. This is the horizontal axis. Okay, that will show the angle here, and then this is a vertical axis here. Okay, on this vertical y-axis we draw the EMF here. Okay, so this is the EMF, and that will be the angle here. Okay, angle it rotates. Okay, the magnetic field rotates. So EMF is between two values here, plus epsilon. Okay, EMF maximum, and minus EMF maximum. Okay, so now you see in the first case the EMF is 0. So put a dot line here. Okay, it's 0. Okay, I'll put another color also. Okay, EMF is 0. Now you must mark the angles now. Okay, so 0, omega t is 0, then pi by 2 means what? 90 degrees. Okay, then 2 pi by 2, that means what? Pi. Okay, 2 and 2 cancels. Pi means 180. Okay, next 3 pi by 2. Okay, that is 270. Okay, then 4 pi by 2. 2 and 2 to the 4, so 2 pi will come. That is how much? That is 360 degrees. Okay. So now we have these different angles there. You note it down. Let's see and plot the EMF here. So first the EMF was 0. So we put dot line here 0. And next you see the EMF will be maximum here. Okay, in the positive direction. So it's maximum in the positive direction. So we put dot here. Next you see the magnetic field rotates and comes this side. So EMF is 0 again. Okay. You see maximum, it goes into the air only now. So EMF is 0. So next you see the EMF comes downwards here, or the magnetic field points downwards, and the EMF will be in the opposite direction, that is S to R and then Q to P. So if you notice it, the EMF is in the opposite direction now, so we'll get here minus EMF maximum, so put dot here. Okay, the last one, the magnetic field rotates here and the EMF is becoming 0, okay, because it goes into the air only. So let us join these points, okay, so that we get the curve like this here. Okay. So this is a sine curve, it's sinusoidal nature. So the EMF produced by a single phase AC generator will be sinusoidal nature, the sine wave. Okay. So this is a very important thing. Go through the pictures here, draw and see in your note. Thank you for watching.